Hello, Eastview Scholars, and welcome to this edition of Sharp Shorts. We're going to continue in our series of how to name chemical compounds, really that follow ionic naming processes, and whether they're ionic or not. And so our discussion today is on acids and bases, and specifically what are called Arrhenius acids and bases. That was just, we'll talk more about acids and bases later in the year, but that was just the first definition of what acids and bases were. Bases are easy, so we'll start with those. By Arrhenius' definition, bases are anything that the cation, or anion, is hydroxide, the negative portion. And hydroxide is one of the two polyatomics we know that ends at IDE, the other one being cyanide. You just have to know them. But the fact that it ends in OH, whether in word or formula, defines it as a base. Okay? And we'll talk about that in a minute. For acids, according to Arrhenius, then the cation was hydrogen. And so the reason Arrhenius started that is then if you mixed an acid and base, they would neutralize each other because the hydrogen would combine with the hydroxide in a chemical reaction and make water and neutralize each out. Acids are a little more complicated in their naming, but let's start with bases. Here they are. We could spend a lot of time on this. We really don't need to. Their recognition that bases are just ternary ions that end in hydroxide. So if I'm naming them like here, I just name the cation and then name the anion, and it's hydroxide. So this first one is just lithium hydroxide. Okay. By convention, as I write that out, then you can see that the last one on this litany of three little things here is calcium hydroxide. The pen's go a little slow today. Thank you. Anyhow, that's it. There's nothing really special to it. It's more of a recognition type thing, and certainly more towards as the year goes on. But it's just that bases are hydroxide. So you just, as you would with any ternary, name the cation and the anion is hydroxide. Here's calcium hydroxide. Here's magnesium hydroxide. Formula-wise, you just write out what it is. Magnesium is a +2. Hydroxide, you just got to get used to that name, that hydroxide is OH -1. Do our charge flip-flop like we've done with ionic compounds. And don't forget your parentheses on that hydroxide, the #1 error that always occurs. And there you go. Put it in parentheses. I need 2 of those for every 1 magnesium. So that's bases. Just don't confuse yourself in your packet as you're working on the sheet that says acids and bases. It's not all acids. Some of them are bases. Acids are compounds with hydrogen as the cation. Okay. And technically, really, because they're nonmetals, hydrogen combining with some nonmetal, other nonmetal, and hydrogen being a nonmetal, they're really covalent compounds, but they follow acid naming because it's a two-step process. You name them as you would an ionic, binary, or ternary compound, and then you use the ending, and here's the key rules, then you use the ending of that thing to derive its acid name, to give it its acid name. So, and we'll do a few examples, but if I did it as a normal binary, ionic, or ternary, if it ended in an IDE, which would mean it's hydrogen with some element, anion, then it has a prefix hydro, whatever the anion stem is, and ic, acid, as the ending. So it's got a prefix and a suffix with the acid. If it's a ternary, hydrogen with a ternary polyatomic, then it's going to end in AT or IT. And if it's AT, then it's just whatever the anion is with ic suffix. If it's an IT ending, then it's whatever the anion is with an us ending. Okay. I think the big thing to point out here is that hydro, the prefix, only goes with binary, basically with binary acids, except for cyanide, which is a polyatomic, but really with binary acids, and the ID ending is the only time you use hydro. A very common mistake is wanting to use hydro in every acid that you name, and don't, because it's defined by its ionic name. Anyhow, let's do a few examples. And here's our examples, and this is what I wanted to point out. The common feature to all of these things is hydrogen. You can see it in the formula here. So I started my ionic naming by just writing hydrogen. Okay. You can see it as I go to the formula. When I see this word acid, the first thing I did was just write H+. Okay, because that's my cation. All right. So step one, name it as it normally would be. Here's hydrogen, here's nitrogen, but we don't say nitrogen with binary stuff. We say nitride. Okay. And that sets me up with my ending, because here's the key part of that, the IDE ending. IDE then for an acid name, as our rules say, then mean that I start with the prefix hydro. And it's the only time I use this prefix is when it has an IDE ending in its ionic type name. Then, excuse me, I start getting a little crazy here on my writing. Then, with the, now I need the anion stem in there. And it was nitride, so it's nitric. Okay, because the anion stem is nitride, I don't know a good way to say that. And then the suffix for ID endings is ic. And then I'd write the word acid. So it's hydronitric acid. Okay. Key being with the ID ending, it's a hydroic acid, and then some derivation of the anion in here. Here is a polyatomic. I see there's more than 3 in both of these. So after the hydrogen, I look for this on my polyatomic chart, and that is nitrate. AT ending. AT endings are defined by the fact that I just then change that for the acid name. AT means it's an ic acid. So again, using the anion stem, which is nitrate, that becomes just nitric acid. Okay. The name is very close to what you saw above, but look at the formulas. They are 2 very different compounds that will have very different, oftentimes because of the oxygen, this will be a much more active and vigorous type of acid. But notice what's not here. I did not write hydro here because that is only for ID endings. For AT endings, the only thing is the ic. Okay. And here we have another. Here's another polyatomic. This one, though, is nitrous. Okay. OUS means then when I convert that to its acid name, oh, sorry. Let me start that again. This is nitrite. Sorry, I was jumping right to the acid. This is hydrogen nitrite. That's its ionic name. I apologize. Okay, NO2 is nitrite. IT then means you go to the OUS ending. I'm sorry, I'm just so used to looking at it and naming it as an acid, I sometimes don't stop to think of what that middle step is. That becomes nitrous acid. And thank you, stylists, for working so well today. There we go. Again, OUS related to ITE. IC goes to ATE. AT and IT, I got to remember to myself, I got to make a note to myself that anything that ends in AT or IT is a polyatomic. And with really one exception or 2 exceptions, the hydroic is an ID ending, meaning it's a binary acid. Okay? Now, here when I'm going to the formula, I look, it's only ic, it's not a hydroic, so it's an ATE ending. I'm doing this backwards. So I go look for something close to phosphorate or phosphate, and if I look at my polyatomic chart, then I have a phosphate that's at -3, that's PO4. So then the formula becomes, doing my charge flip-flop, H3PO4. I'm just using the rules backwards, but this is what helps me figure it out. Here is hydroic. Hydroic means IDE, and if I think IDE, I have to think of an element. Okay? Unless it's cyanide, I have cyanide memorized. There's only 2 polyatomics with the IDE ending, and that's hydroxide, which are bases, and cyanide, which can be an acid. But if I look it up then, what would be phosphoride is phosphorus, which is a -3 in valence electrons. So again, charge flip-flop means that that's H3P. Okay? So I just have to work with this enough to get used to knowing those rules. I recommend that you, when you're doing the words, you write it out first and say hydrogen, do the ionic name first, write it out, see the ID, AT, or IT ending, and then convert it to its acid name. Here's our last one. Us means ITE. ITE means it's on my polyatomic chart. I go to my chart, I see something called phosphite, which is very similar to phosphate, but it's got 1 less oxygen. It's also a -3 charge. I do my charge flip-flop, and that is H3PO3. Okay. So that's really it. It's important that you are able to do the 2 steps and recognize what the ending is and relate that to the rules, and then be able to balance out the charges. Anyhow, go practice on your packet and scholar up, Eastview.